Hello, class. I want to start with today's lesson as the ideal gas law. You should have picked up a worksheet from the pickup table, and it should look like this on your desk. So let's run down a little bit about the ideal gas law, and we're going to work a couple of problems, or actually we're just going to work one problem, and then I'm going to let you have the rest of the class time to finish working on that. So if you look at the ideal gas law, you notice that you've got PV equals nRT. So here is our gas law that we're working with. Pressure times volume equals N, which is something that we haven't really talked about very much. Number of moles is what you're looking at of your gas. And then R is something new as well. R is called the universal gas constant. I'm going to show you how that number was derived. If you notice, its units are liters times ATMs over moles times Kelvin. So the way that the ideal gas law constant was derived was if you have the standard molar volume of a gas, 22.4 liters, remember that that is equal to 1 mole, so 22.4 liters, and notice it's times ATMs, so the number of ATMs that's standard would be 1 ATM. Okay, so we're going to multiply those. And then on the bottom, you've got moles times Kelvin. So again, we're going to use the standard units for that. So 22.4 liters is equal to 1 mole. That is standard. And then the standard temperature is 0 degrees Celsius, but we always have to change it to Kelvin, so 273 Kelvin. Now, when you take 22.4 and you divide by 273, I invite you to go ahead and get your calculator and do that. Just 22.4 entered into your calculator, divided by 273. You'll notice that you will get the ideal gas law constant. Okay, your calculator should say 0.08205512. Well, we're going to round that to 0.0821. Now, the ideal gas law constant allows us to put all the variables in one equation without having another set of conditions. Like in all the other gas laws we've looked at so far, we had 2 pressures or 2 temperatures or 2 volumes. The ideal gas law does not have 2 of each one. It has 1 pressure, 1 volume, 1 number of moles, and 1 temperature. That's because the universal gas law constant is going to include all of those things in it. That's the only way you can have every single variable in one equation without having another one of those same type of variables. You have to use the ideal gas law constant. Now, because the ideal gas law constant is in very specific units, your volume has to be in liters, your temperature has to be in ATMs, your grams, if they give you grams, has to be in moles. You're going to have to convert that to moles, and your temperature, of course, is going to have to be converted to Kelvin. So if I'm talking about what is the hard part of what I like to lovingly call PivNert, that would be the part that's the hardest, is making sure that you convert everything into the proper units. So we're going to do number 4 together so that you can see this process. And this particular worksheet that you're given has pretty much, you're going to have to convert pretty much everything all the way through it. So looking at number 4, though, it says, at what temperature will 5 grams of Cl2 exert a pressure of 900 torr and a volume of 750 milliliters? Now, if you will go ahead and identify what variables you have, this is going to make your job a lot easier. Grams can be converted to moles. Okay, we hopefully know that at this point. So that will be your little N. I'm going to put a little N above that. 900 torr, it tells me that that's pressure. So this is my P. Okay, and my volume right here is here. And then I'm looking for the unknown. My unknown value is, or variable is T. It says at what temperature. So when I set up my problem, I'm always going to, personally, I would always write PV equals nRT. And then you can plug in your information underneath it and you know you have things set in the right spot. But before we plug anything in, we need to see, do we need to convert anything into the unit that is required for PIVNERT? So let's look at our pressure. Notice our pressure is at 900 torr. Well, our pressure has to be in ATMs according to this right here, right? So we cannot just automatically plug in 900 torr. We're going to need to do conversions on that one, okay? So if you look at the marker board, if you're in my classroom, then you should see that 760 millimeters of mercury is equal to 1 ATM. So if I divide 900 by 760, then that'll get rid of torr, and I will be in ATMs, and then I can just plug into my gas law. This writing is painfully slow, but I want to go ahead and get, there we go. So torr would cancel out, 900 divided by 760. So you go ahead and plug that into your calculator with me so you understand what I'm doing. And I got 1.18. So that's our pressure that we're going to go ahead and plug into. I'm just going to put it underneath the ideal gas law where it belongs. So pressure would be 1.18. Now I'm looking for temperature. So right now I'm still going to need a volume. So go ahead and make my parentheses for volume there. Over here we have volume, and it's in milliliters. Well, hopefully at this point you recognize that there are 1,000 milliliters in 1 liter, okay? So we need to divide this number, 750 milliliters, by 1,000. That way our milliliters would cancel out and we'll be in liters. So 750 divided by 1,000 would end up being 0.75. You could just move your decimal point over 1, 2, 3 spaces. And so I'm going to go ahead and plug in 0.75 for the volume. And I'm going to include that 0 with it. Okay, close those parentheses. Equals our number of moles is the next thing we're going to plug in. Now, number of moles is going to require a little bit more effort because the other ones, if it's in torr, divided by 760. If it's in milliliters, divided by 1,000. But when we have grams, we have to convert that into moles. And so that's where our periodic table comes in. I know this never goes away. We have to constantly keep using it. That's why we learned it in the first place. So I'm going to set up my little dimensional analysis. It's a one-step problem. And I need to look up chlorine on the periodic table. Okay, I see it. And it weighs 35.453. But I have 2 of them. So I'm going to need to multiply 35.453 times 2. And I got 70.91. That goes down here on the bottom because that is grams. And remember that that's equal to 1 mole of chlorine. So grams and grams will cancel out, and that will give me some number of moles. So I'm going to plug that into my calculator. 5.00 divided by 70.91. Okay, and I'm coming up with 0.0705. This is very painful. Okay, now I'm going to take that and plug that into my ideal gas law over here. Okay, so I have, I'm just going to say 0.0705. Hopefully you're listening and you can hear my voice better than you can see my handwriting. All right, and then we've got the N taken care of, and now we're going to plug in R, and our R value is this number, 0.0821. So plug it in, plug it in. And then last but not least, temperature. We don't have temperature, so that's the variable that we're going to be solving for. Okay, at this point, hopefully you understand that you need to isolate T. So we're going to move everything that's beside T on the other side. So we're going to divide by 0.07, it's supposed to be a 7, 0.05. And so that would cancel out. And then we're also going to divide by, and I'm going to put a little time sign between these, because in your calculator, you need to make sure that you're not multiplying by this number, by the 0.0821. You have to divide by it as well. So don't tell your calculator to multiply by it. You need just open parentheses, put 0.0705 times 0.0821. Oh my goodness. Okay, close parentheses. Now I'm going to plug this into my calculator and let's see what I get. So I have 1.18 times 0.750. I hope you're doing this with me. Enter, divided by parentheses 0.0705 times 0.0821. Close my parentheses, and I get 152.9 for my answer. Okay, well, I'm going to round that to 153, and the units that are going to go behind that are, of course, for temperature in a gas law would be Kelvin. So the final answer on this one is 153 Kelvin. You don't have to convert that back to Celsius if you don't want to. I'm not going to ask that you do that. Today is just practicing, making sure that we can convert everything else and use the ideal gas law to come up with our answers. Now, if you notice over on the right-hand side of the marker board, the answers for 1, 2, 3, 7, 8, and 9 are up there. I should see all of your work on your paper, because just giving me an answer is not going to cut it. You've got to show me your work. You've got to practice. So you're going to eliminate, don't do 5 and 6 today. Don't totally scribble them out, because we will come back and do those. And also don't do number 10. Just make sure that you complete in class today 1, 2, 3, 7, 8, and 9. If you need another sheet of paper, grab another sheet of paper and staple it together. You could also use the back of this worksheet, because there's nothing on the back. All right, guys, I will see you tomorrow, and I will be able to answer questions. But you guys help each other out, because you just might have a little bell ringer quiz tomorrow, making sure you know how to use the ideal gas law. So work out your problems while you're in class, and don't waste your time. I'll see you tomorrow. Okay, stop. And I need to stop.